All right, we just have a quick lesson to learn here for today. Make sure that before you start this, you went and checked your answers for your homework last night on solving radical equations. I left a video there for you that displays the answers, and if you have a question on one of them, like you didn't get an answer right, then go and watch the video for that problem to make sure you clear up any misconceptions and things that you got wrong. And actually, I guess in the video I showed the answers, but there's a file in the folder with all the answers, like an answer file. All right, here we go. So today you have to learn about inverses, and this is not day 5, this is day 8. So just change that for me, I'll change it on your file, but anyway. All right, this is the last thing we have to do in Unit 5. So recall from earlier in the year, we did do work with inverses before, and I also went over this with you last class, where like if you have a coordinate, like let's say you have the point 2, -5, if you're going to do the inverse, remember you switch the x and the y, you switch it to -5, 2. Like you literally just like change places, right? The x and the y change places. And so if you have that in an equation, we did this earlier this year as well, you have to switch the actual letters, right? So if I wanted to do the inverse of y equals 2x plus 6, remember that's a line, so if I do a little quick graph, starts at 6, goes up 2 over 1, up 2 over 1, there's a line, if we can kind of sketch it a little bit. So if I want to do the inverse, I switch the x and the y. So I make it x equals 2y plus 6. Then I have to resolve the equation for y. So I'm going to take away 6, so I have x minus 6 equals 2y. And then I have to divide both sides by 2. So the easier thing to do is to just divide every single part by 2. That way you have your slope and your y-intercept separated. So if I solve that out, so I'm going to put my y over here, I get 1/2 x, because there's a 1 in front of the x, and then minus 3. Right, and so then when we go to graph that on our picture over here, if I start at -3, maybe about like right here, I go up 1 over 2, up 1 over 2. So when you graph that, remember that this graph was kind of special. When you graph a function, the original function, and its inverse on the same picture, if I make that a little longer, remember there was this line right in the center of the graphs that kind of divided them in half, right? This was the line y equals x, because that's what they're symmetrical over, because you switched the x and the y values, right? So if you had a graph, you could kind of tell that they were symmetrical based on that line that kind of cuts them in half. This is like their line of symmetry. All right, but anyway, here we go. So we are going today to learn how to find the inverse of a cubic function or a cube root. All right, so that means, so f of x, remember, is the same thing as y. So I'm going to turn this into a y to make it easier on myself. So my first job is to switch the letters, right? I make this x equals, this becomes y minus 2 to the third plus 1. So notice, all that happened was the x and the y switched places. Nothing else moved. The 2 stayed, the cube, the 1. All right, but I got to solve this for y now. So the reason we waited to do this is because you just learned how to solve things, especially with cube roots and cubes and back and forth. All right, so we're going to take away 1 to clean this up. So I got x minus 1 equals, I still have this y minus 2 to the third. So to get rid of a third power, I do a third root. And so we had to wait till we did cube roots and things like that so you would know what it meant. So I'm going to do a cube root on both sides. So you have to do the cube root on both sides. Whoa. Oh, I can't get that 3 to right there. Hang on a second. Ah. Let me see if, there it comes. All right, there we go. The cube root on both sides. And so what happens, the cube root here knocks out the cube power there. And so out pops y minus 2. And over here I have the cube root of x minus 1. I just have the cube root of x minus 1. There's nothing that I know about that. I just leave it like that. And so then I need to bring my 2 over to the other side, so I'm adding 2 to both sides. And I'm going to, write it, and this is kind of backwards. I'm going to write my y equals over here. So what I have right here is cube root of x minus 1, and the plus 2 is on the outside of the cube root, so plus 2. All right, so there is your answer. Now, if you want to be more specific or more perfect about it, remember that f of x is a notation. So f negative 1 of x, remember that meant the inverse. So cube root, y, oh, not y, cube root x minus 1 plus 2. All right, so that would actually be like the best, most final answer since it did start out with f of x. All right, so that would be the better answer to write. Now I want you to notice a couple things here. So notice that, this cubic function goes right 2 up 1. Notice how the 2 was on the inside, but now it's a minus 2 and it's a plus 2 on the outside. Notice that there's a 1 on the outside and there's a minus 1 on the inside. Notice there's a cube, now it's a cube root. So everything's like opposite, right? So if it was inside, it goes outside. If it's outside, it goes inside, and the opposite sign. Cube root. So just notice that, and then sometimes you can do these problems without showing a lot of work, but we do want you to show your work on your homework tonight. All right, here, switch it. So let's do x equals cube root of y minus 1. And immediately, to get rid of the cube root, I have to do the cube power. So notice this is a cube root right now. So I expect this to turn into a cube power. So I'm going to do cube power. This also has to get a cube power. So these knock each other out. Out pops y minus 1. And over here, x to the third. So this is x to the third. So plus 1, plus 1. And so I have y equals x to the third plus 1. And that's it. I mean, it started off as a y, so I'm just going to leave it a y here. Okay, so that's the general gist of it. Here's just a couple more examples we're going to do. This is a cube power, so I'm going to get a cube root for the inverse. So this is a y, remember, so now let's switch it. X equals 5y to the third plus 4. So I got to clean this up and get the y alone as much as I can. So I'm going to take away 4. So I have x minus 4 equals 5y to the third. I can still divide by 5. It's nothing detached here, so I'm going to divide by 5. I'm just going to divide the whole side by 5 like that. So now what I have is I have y to the third equals x minus 4 over 5. I switch sides just to make it more what we're used to. But now, since I want to get rid of a third power, I'm going to apply the cube root. So this whole thing over here is in the cube root. Okay, so these knock each other out, and out pops y equals. I just got a cube root of x minus 4 over 5. And that's it. This was f of x, so I'm going to write f negative 1 of x equals cube root of x minus 4 over 5. So there's really not a lot to do. Like, you're not evaluating anything. Whoa. You're not evaluating anything. You're just, like, rearranging it, right? Like over here, like you're not doing the cube root of x minus 4 over 5, you're just writing that. Over here, there's nothing to do with this cube root of x minus 1. You just write it and then you add stuff or, create things around it. All right, this last one, this is a cube root, so I expect a cube power by the time I'm done. All right, so remember this is y, so I'm going to switch that to x equals cube root y plus 4 minus 7. All right, so I need to move the 7 so I can get this cube root alone. So I got x plus 7 equals cube root of y plus 4. All right, so now is the time to get to that y inside. You need to apply a cube power to make it pop out. Cube power, and this is what I mean. X plus 7 to the third, you're not multiplying that out. You're just going to write it down. I don't know. I do know, but I'm not going to do x plus 7 to the third. I'm just going to write x plus 7 to the third. You don't actually work it out. You just write it, and then this part pops out because these cancel. And then all you're going to do is move the 4 over there. So the 4 becomes a negative 4 when it moves over, or you can do this and show that you're subtracting 4. Okay, so you got y equals x plus 7 to the third, and then this minus 4 behind it. So more specifically, f negative 1 of x equals x plus 7 to the third minus 4. Okay, and that is it. That is how to find the inverse. And so that's really the only thing you're doing here. You've kind of done it before, but you're doing it with a new function that you've never seen before. And so the last little part is we're going to look at the couple graphs here. So this kind of looks like a cubic function, right? And so we're going to draw the inverse. So remember, for the inverse, we just have to switch points, right? I have this point right here, negative 5, 0. So negative 5, 0. I'm going to switch it to 0, negative 5. So 0, negative 5 is down here. Okay, so I did that one. Let's do this one right here, negative 4, 3. So negative 4, 3. I'm going to switch to 3, negative 4. So 3, negative 4. Okay. And let me do one more in the middle just so I have a path to follow. That's negative 4.5 and up to 2. So negative 4.5 and up to 2. I'm just picking some so I can follow a path. So I'm going to do 2 and negative 4.5. 2 and negative 4.5. So that way I can kind of see that this graph kind of goes like this, right? Like it curves that way. All right, so then moving on, I think I can go ahead and like maybe do it right about there. We'll call that negative 2 and we'll say 4. Negative 2, 4. So I switch to 4, negative 2. Right, so that is curving up there. And then up at the top here, I got negative 1, 6. So I do 6, negative 1. So that's coming up to there. Okay, and so also remember this is a place where you can draw that line y equals x across the middle, and everything should be symmetrical. You see how it kind of follows the same curve there, and it like there, it's like you know, symmetrical over this line right here. Okay. All right, so this last one doesn't really have anything to do with cubes or cube roots. It's just a problem about inverses. This is actually an old SOL question. So it says point A lies on the graph of 1/2 x, y equals 1/2 x plus 2. So great, that's this line, right? F of x equals 1/2 x plus 2. It starts at 2, up 1 over 2. Like that's literally this line. Locate the image of point A that lies on the graph of this. So you have to know that that notation means inverse. So it wants the inverse of point A. Locate the image of point A that's on the graph of the inverse. All right, so point A. Point A is the point negative 2, 1. So negative 2, 1. So all I have to do is do the inverse of that. So the inverse of point A is, let's see, 1, negative 2. So all I have to do is go on the graph and go over to 1, negative 2, and that's all it wants. It doesn't want the whole line. It's just really didn't really even need to give you this line. Like it was just like extra information. All right, so your job is to do these problems on this page. You got a couple inverses to find. You have a graph to do the inverse of, and then down here, I have just a few old problems, just review problems, a couple equations to solve like you did in your homework last night. And then I got just like a graph, tell me about the transformations, you know, up, down, left, right, like when you go from here to here, like what are the movements? And then this one here, I want you to graph that. Remember, you can use Desmos if you want, or you can probably just graph it. And tell me the domain and range. And that'll be it. We'll see you next week. Bye-bye.